Okay, so let's look at some R code to see how we could actually construct a Bootstrap distribution, again using the birth data from North Carolina. And so this file, this R code that we're looking at is in a file, I think it's called like North Carolina births.r. So you can find that in posted in Canvas. So you can open up that file and file along, but I'll kind of explain what's going on in this code. And so first step, right, is we load up the resample data library if you haven't done that. And what we're going to do, rather than create all 1009 raised to the power of 1009 possible Bootstrap resamples, that's going to take a really long time. We're going to generate enough. So we'll do like we did with the permutation tests. Let's just say 10 to the fifth, 100,000 samples. That should be sufficient. And we're going to create this empty vector called result, where we're going to store each of the, in this case, means that we calculate from each of the Bootstrap samples that we generate. And so over here, I defined a new variable called weight. This is going to be a vector that contains all 1009 weights that were in the original data set. And so we're going to use a for loop to construct each of these resamples, each of these Bootstrap samples. So we're going to start at 1, and we're going to stop once we've got 100,000 Bootstrap samples. And so X is denoting each Bootstrap sample that I create. So I'm going to go into the variable weight, which has the 1009 weights. And I'm going to, so the first entry in this sample command is what vector, what are we sampling from? So we're sampling from the weight vector. The next command is how many values are you going to pick from that vector, from that variable? We're going to pick 1009 because we want each Bootstrap sample to have the same number of values as our original sample. And now we've used this command before where we didn't want to replace our values back in when we were doing permutation tests. But now with Bootstrap samples, each time you pick a value, we do want to put it back so that it could possibly be picked again. So now we set the replace option to be true. So this command right here is picking a Bootstrap sample, 1000 values picked with replacement. And then the next line in our for loop is to take all of those 1009 values that you just picked and calculate the mean of those. If we were trying to describe a variance or a proportion, then we might choose something other than a mean. But here we want to come up with an estimate for the mean weight of newborns. So for each Bootstrap that we pick, the statistic we're interested in is the mean, and then we're going to store that in result and repeat. And we're going to do this 100,000 times. And then if we want to see a picture of that, we can create a histogram. So this histogram is going to display all of the means that we calculate, all of the values in result. So remember, this is storing each of the means that we calculate from each Bootstrap sample. And so let's take a look at what the output of this code is. And I should just say these last two lines here, this is going to calculate the mean, the center of the Bootstrap distribution, and this is going to calculate the standard deviation of the Bootstrap distribution. So here's what we get, and notice, as you might suspect, we can see that this is normal, as was the case with sampling distributions. And the center of the distribution, we've got the expected value for X bar. That is almost the same as our original sample, but not quite. Okay, so our original sample actually was 3,448.26. Okay, so it's very, very close to that. And we can see here the standard deviation, which I'm going to call the Bootstrap standard error, is about 15. So this is going to help us when, again, the whole point here is we wanted to come up with an estimate for what is the mean weight of out of all newborns in North Carolina in 2004. From our sample, we saw that it was about 3,448 grams. It's not going to be perfect, so the standard error is going to be a useful way for us to build in some uncertainty, some error in that estimate.